Alright guys, so today we're going to talk about average rate of change. So this is basically slope of major functions. Normally when we find slope it's only of a straight line, but average rate of change between any 2 points is the slope of the line that has those 2 points on it. Alright, so whereas you've got this curve that happens and those 2 points might be here and there's a bump in the curve along the way, what you're basically doing is just finding the slope between those 2 points. That is what average rate of change is. It's also called the secant line, but typically I just say it's the average rate of change, and you'll see me abbreviate it ARC a lot. So, the slope formula, if you guys remember it, is basically change in y divided by change in x. So y2 minus y1 over x2 minus x1, which you can, in function notation, say it's the function value of your first x value minus the function value of your second over b minus a, and b minus a are your two x values. Just make sure that whatever you do, you're going in the same direction with the points. If you're going left to right, make sure you're going left to right with the y's and left to right with the x's. If you switch them, you're going to end up with the wrong sign. Okay? So, we're going to start by finding the average rate of change using just the formula. So, the formula is f of x minus f of c over x minus c. In this case, we're given f of x, that's the function, so 5x. And we're given a c value, and in this case, I want you guys to assume, because I'm finding the average rate of change between 1 and x, that 1 is your c value. Okay? So c is equal to 1. Now, the deal with these is I'm not giving you 2 points, because if I'm just going to give you 2 points that say, tell me the average rate of change between them, that's finding slope, and you guys have been doing that since Algebra 1. We take this up a notch, and it's basically between the function value itself and a specific point on the function. Does that make sense? So, you're typically going to end up with the whole function, plus or minus whatever the other value is going to be, and so you're still going to end up with x's in your answer a good majority of the time. Okay? So, for the first one, f of x is my 5x, so I'm going to plug that in for f of x, minus f of c. Now, f of c is what?
1, or no.
I plug 1 in for x and I get 5 over x minus c, and c is 1. Okay? So really what you're doing here is you're finding your average rate of change, and you're taking f of x minus f of 1 over x minus 1. And plugging it all in, this is what I get. Can I simplify this? Yes, what do I do? Take out the 5 on top, so I now have 5 times x minus 1 over x minus 1. So my average rate of change is
5.
5. Simple enough? Alright. So, if we go from there and look at the next one, we're taking it up a notch. It now has an x squared. So again, same concept. Your average rate of change is going to be your f of x minus your f of 1 over x minus 1. So f of x is x squared minus 1 minus, what do I get when I plug in 1? 1 minus 1, right?
Yeah, 0.
So really I have just x squared minus 1 over x minus 1. Can I do anything with the top? Isn't that a difference in squares? So can't that become x minus 1, x plus 1? So in this case, my average rate of change is what? X plus 1. So you can't be afraid if you end up with an x in your answer, so, okay, well I must not have done it right. You did it just fine. That's what happens sometimes. The reason why the first one gave us 5 is because it's a straight line, right? 5x is just a straight, nice linear line. So you're always gonna have the same rate of change between all the points, it's always gonna be 5, because that's the slope of the straight line. This is a parabola. So the change between any given points is gonna be whatever your x value is plus 1. It's gonna be your average rate of change, your slope between any 2 points. Alright, so try the last one on your own. That one doesn't work, I've got little ones up here too. See if that one will work if you want to do. You can have a replacement for 9 seconds. Alright, so what does your fraction look like before you start to simplify it?
2 over x squared.
2 over x squared minus what?
2.
2, because you're taking, you're dividing it by 1 over
X minus 1.
Alright, so the first thing you need to do when you start simplifying things like this is to do what?
Get the fraction away.
Get that x squared out of the denominator of the numerator, right? We don't want fractions within fractions, so multiply every term by x squared. Put 1 in there. 2 divided by 1 is 2. So for the first one, the x squares cancel, and I'm left with 2. Minus 2 times x squared is just 2x squared. And then on the bottom, I have, you could do the whole distribution in and get x cubed minus x squared, or you could leave it out and do just x squared times the x minus 2. And as I've said before, like, don't distribute that bottom piece in unless you absolutely have to, because there's a good chance something's going to cancel. So,
Pull the 2 out of the top.
pull 2 out of the top. Now what?
You can make it x minus 1 and x plus 1.
You could do that, except for you can't do x plus 1, x minus 1, because where's the x?
Oh,
It's
x.
after
so
the
I can
minus
take
sign.
out the negative.
So what if instead of this step, and I'm not saying this step is wrong, but why don't I kill 2 birds, 1 stone, 2 birds with 1 stone, by pulling out a negative 2? Alright? If I pull out a negative 2, doesn't that make the x squared positive? And it makes that 2 a negative 1. Now I can do exactly what you're saying and write it with the x in the front. If I did what he was saying before without pulling out that negative, I have to write 1 plus x, 1 minus x. And then you'll end up having to pull a negative out later. So now I have the negative 2, x plus 1, x minus 1, over x squared, x minus 1.
And chaos.
Okay, you've got something that cancels. And that leaves you with a negative 2 x plus negative 2 times x plus 1 over x squared. Is there anything else I can do with that?
I want to say yes, but I'm not sure what.
Well, I'm gonna make your life a whole lot easier until you're done. There's nothing else you can do.
Okay.
This is the average rate of change between 2 points on that rational function curve.